A designer is working on a new roller coaster and she begins by making a scale model. On this model, a car of total mass 0.5 kilograms moves with negligible friction along the track shown in the figure above. The car is given an initial speed V0 is equal to 1.5 meters per second at the top of the first hill of height 2 meters. Point A is located at a height of 1.9 meters at the top of the second hill, the upper part of which is circular arc of radius 0.95 meters. Calculate the speed of the car at point A. On the figure of the car below, draw and label vectors to represent the forces on the car at point A. Calculate the magnitude of the force of the track on the car at point A. In order to stop the car at point A, some friction must be introduced. Calculate the work that must be done by the friction force in order to stop the car at point A. Explain how to modify the track design to cause the car to lose contact with the track at point A before descending down the track. Justify your answer. Let us calculate the energy at this point, and then we will equate that energy at point A. As we know, because of the law of conservation of energy, the total energy is conserved or the total energy of the system is constant. That is how we will equate the energies. So E top is equal to E at A. At the top of the hill, the roller coaster car has both the gravitational potential energy and kinetic energy. But at A, it has only the kinetic energy because we are taking point A as the reference point. Okay. Now, let us write the height. What is the height? When we take A as the reference point, the difference between the hill and the point A is only 0.1 because this is 2 meters high. The hill is 2 meter high, and then point A is at a height of 1.9 meters. Therefore, the difference is only 0.1. That becomes the height here, mgh. To find out the gravitational potential energy, we use that height. Okay. So here in this equation, mgh is equal to half mv square is equal to half mva square. Mass goes off. We are left with other quantities, and then plugging in the values, we will get the va value. That means the velocity at A is equal to 2.05 meters per second. Next, this is the free body diagram for the car at point A. So Fn and Fg are balancing each other. Fn is equal to Fg. Okay, or Fn minus Fg here. The resultant force, that means Fn minus Fg contributes to the centripetal force. The centripetal force is acting vertically downwards. Fn acts upwards and then Fg acts downwards. Therefore, Fn minus Fg is equal to minus Fc, or Fn is equal to Fg minus Fc. So inputting the values here, we found out, we can find out Fn is equal to 2.9 newtons. Okay, next. In order to stop the car at point A, we have to find out the work done by the friction. So here the car should stop. That is why it should be negative. Work done by the friction must be equal to negative kinetic energy. Our kinetic energy must be equal to negative of work done by the friction, because you know work done is equal to F dot D cos theta. And then here theta must be 180 degrees. Okay, 180 cos 180 is equal to negative 1. So this must be equal to minus 1, but then must be negative 1. So opposite direction. The force and displacement should be in opposite direction. That is why I put it as W friction is equal to minus Ka. So again, plugging in the values, mass 0.5 and then velocity 2.05, I will get the answer as negative 1.05 joules work done by the friction. Okay. Now, explain how to modify the track design to cause the car to lose contact with the track at point A before descending down the track. Justify your answer. So for that, Fn is equal to, he is asking us to find out the when the car will lose the track. When it will lose the track, here you see Fn is equal to mg minus v square over r. Suppose if this becomes more, then once the car loses the contact with the track, it will be under free fall. So v square minus r must be equal to g. Then only it becomes 0, and then fn becomes 0. That means under the free fall, like that. Okay, that is the situation. So what should be, so to make fn is equal to 0, g is not in our hands, and then mass is constant. So we can change only v square, v and r. So to increase the v and then to decrease the r. To increase the v, what we have to do? We have to increase the hill height. Okay, r we have to reduce this circles. This point A should be down, and this should be more higher than A. Then only mv square, this v square becomes more. Okay, and then the next one is R should be less. R should be less means this circle's radius should be less. R again, this should be small. This radius of this circle, this circular path, this should be less. On and on, this should be lesser than this one. Then only Fn becomes, the car will lose the track. That's the condition here. Okay. Hope this helps. Thank you. Bye-bye.